Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhaumik, and in this lecture series of STR, that is Special Theory of Relativity, we will be talking about the consequences of STR, that is the time dilation and length contraction. In this video we will talk about time dilation, in the next video we will talk about the length contraction. So exactly why do this time dilation and length contraction occurs? Let's see one thing. Suppose, let me explain one thing properly. Suppose you are in a train and you are standing on a train and you have to cover a distance of 100 meter. Now this train is moving with a speed, say something c, and you are moving with a velocity v. So you are actually moving with a speed say, and this train is moving with a speed c dash and you are moving with a velocity v, and this c dash is less than c but only by some value. Let's say c is equal to c dash plus some h, where h tends to 0. That means this c dash is actually tending to c, but it is not equal to c, because according to because we know already that any object that cannot move with speed of light, we'll see that later. Why we'll see that later? Because it will have infinite mass. I'll tell why. Now what we can say here from here is that if this velocity v is sufficiently large enough, then this c dash plus v, that is actually is equal to c, this actually is equal to the speed of the train, speed of the man with respect to the ground, this c dash plus v, that can go greater than c. It may happen this train is moving with some c dash that is just less than the speed of light, and what will happen if this person is moving with the speed v? So this person can actually cross the speed of light, that what our classical physics say. But actually that doesn't happen, because in classical physics we assume that time is an absolute quantity. But here what will happen? Here this time will change. This time will slow down. It will increase. So that this speed automatically decreases. Or the effect of the speed decreases. The speed will not decrease, the effect of the speed will decrease. So this is actually called time dilation. That means time is not absolute. Let me give you an example with the help of a spaceship. Suppose you have a spaceship here. This spaceship has a mirror and there is a laser light here. This laser light is going up and it is reflected, and laser and detector. There is a laser and detector here. This distance, let me assume it as d. So here I can say that from this example I can say that let this distance be d. So here to find the time dilation, what I can do here is that the velocity of light, that is c, this will be my 2 times the distance 2d, this light is traveling 2 times, divided by 2d divided by the time del t, or say t naught. Let me write here t naught. So t naught I can write 2d by c. Now let's see another case where this spaceship is actually moving. Here is my mirror, and here is my laser light. So now what is happening exactly? This, to an observer who is outside, he will see that this light is actually not moving like this, rather it will move like this, and let this distance be L. Let this distance be L, and let this distance also be L, and this distance is D. So if I find this distance, let's say this distance, this will be root over of L square plus D square. So the light is actually traveling a total distance here, T is equal to into root over of L square plus D square divided by del T. This is the speed of light. And if I consider the linear velocity of the spaceship, then it will be V is equal to 2L by del T. It is traveling a total distance of 2L in del T time. Now let me write all the equations once. This T naught, that is initial case, this is 2D by C. Here again I was getting C in the second case of the spaceship, that I am getting root over of 2 into root over of L square plus D squared by del T. Then for the linear velocity of the spaceship, that is root 2L into 2L by del T. Now let's combine them. Let's put the value of L. L is V into del T by 2. So C is equal to 2 root over of V square del T square by 4 plus D square divided by del T. So I can take del T common and I can divide del T, I can square it. I will get C square will be V square, this 2 and this 4 will cancel, plus 4D squared by del T square. So if I take del T at one side, I will get 2D by C divided by 1 minus V squared by C square. 1 minus V squared by C square 1 over 1, that is I will get del T is equal to, this part is I can say T naught into gamma. Del T is equal to T naught into gamma. So this is my equation. Now let me see once more. This del T, that is the time taken in a moving spaceship, that is time taken at rest, into gamma, and we know gamma is less than 1. So del T is equal to T naught into gamma. So the time taken here is actually more. The time taken is more. Time taken in moving frame is more. That means what is happening here? Time slows down. Time is slowing down. So now we are understanding why the person who is walking on the train will never cross the speed of light. Okay. So that's all for this video, and if you like our content, then please subscribe to our channel and click on the bell icon. Thank you.